If you haven't subscribed, ensure you do so. There is evidence that elephants communicate via infrasound, generating rumbling vocalizations as low as 14 Hz that can travel up to 10 kilometers. The intensity level of these sounds can reach 103 decibels, measured a distance 5.0 meters from the source. Determine the intensity level of infrasound 10.0 kilometers from the source, assuming the sound energy radiates uniformly in all directions. Right, so given the information 103 decibel and also the distance here, so we can use this information to calculate the intensity of these sounds, because what we've been given, this is just the same as intensity level, just the same as decibel level. So we can use this information to calculate the intensity of these sounds. So intensity is given by constant IO 10 to the power B over 10, like this, right? So IO, this is the constant of the threshold. So this is usually taken to be the threshold of hearing, right? So this constant is 1 times 10 to the power negative 12 watts per meter squared. So that's the threshold of hearing, right? So all this information we've gathered will substitute in this formula. So the decibel level we've been given to be 103, and we have substituted like this here. So when you punch this on a calculator, you are getting the intensity to be 0.019952623 watts per meter squared. So that's the intensity by that intensity level we've been given of 103. So we've mentioned to say intensity level is just the same as the decibel level. So we have calculated the intensity of these sounds. Let's also now calculate the power. Alright, so intensity of spherical waves is given by intensity is equal to power over 4 pi r squared. So this is the formula here. So we have calculated the intensity to be this here. So we'll substitute this here, and when we substitute, we are getting this. So then we'll substitute where there's pi here, we substitute with 3.142. Then where there's r, that's the radius, so radius squared, we'll substitute with 5. So when we punch this on a calculator, we are getting 314.2. So we can cross multiply, we are getting power to be 6.269114147. So we can write these to two significant figures to be 6.3 watts. So that's the power, right? So at this point, since we have the power now, we can use the formula this to calculate the intensity at the distance that they have given us, which is 10 kilometers. So let's see how we do it. Right, so intensity of a spherical wave is given by that. Then we have calculated the power to be 6.3, so we have substituted here. Then we substitute here where there's pi, we substitute with 3.142, that's the value of pi. Then where there's radius, they've said 10 kilometers, so 10 kilometers, that's 10,000 meters. Then we square it, right? So when we punch this on a calculator, we are getting this figure here. Then the power we calculated, we said it was 6.3. So this is what we have written here in 3 significant figures. So at this point, when you punch this on a calculator, we are getting the intensity to be 4.9881557 times 10 to the power negative 9 watts per meter squared. So this is the intensity of sound detected at radius 10 kilometers from the source. So this is the intensity of sound. So now let's calculate the intensity level, or in other words, the decibel level. So to calculate the decibel level is given by this formula here. So we said IO, this is a constant threshold of hearing, which is 1.0 times 10 to the power negative 12. So when we substitute, this is the intensity the intensity we have calculated the intensity level detected at 10 kilometers from the sound source. So we substitute in the formula here. Where there's intensity, we substitute with this value. This is what we have written here. Then where there's IO, we substitute with this constant 1.0 times 10 to the power negative 2. So when we punch this on a calculator, we are getting the decibel level or intensity level to be 36.9794009 decibels. So this is what we are getting. So this can be written into 2 significant figures, and we are getting 37 decibels. So this is the intensity level detected when at 10 kilometers from the sound source. So as we have mentioned earlier, to say intensity level is just the same as decibel level. So this is what they required us to do. Thanks for watching. Remember to subscribe to our YouTube channel.